So today, we're going to do coordinate geometry, and our Common Core standard is G for geometry course, GPE, and we're going to, and it says use coordinates to prove geometric theorems algebraically. Okay. Use coordinate proofs to prove geometric theorems algebraically. And again, if I were king of the day, if it was my choice, I'd get rid of the two-column proofs, and this is what we do. A little bit more practical, okay? So example 1. So if I read it, what we want to do is prove that it's a right triangle, okay? And then we also want to find the midpoint, and we want to show the areas twice. So there's 3 things we have to prove in here. So to do it algebraically, first of all, let's go ahead and graph it. So let's graph 0, 6, 1, 2, 3, 4, 5, 6. There's A. 0, 0, which is B. And C, which is going to be a 4, 0. 1, 2, 3, 4. Okay? I'm going to go ahead and draw in my triangle. So there we have our triangle. So now what do we have to prove? Okay? That's a right triangle. Well, it looks like a right triangle, doesn't it? But that's not your proof. You have to prove it. You can't just make these blatant statements. You have to prove it. How can we prove this? Well, what do you know about a right triangle? 9 degrees, right? Okay. Oh, Pythagorean's theorem is not a bad way to prove it either. I wasn't going to do it that way, Claire, but that's actually a pretty clever way to do it. I was going to do it by slopes and opposite slopes and show that's perpendicular. But your way is correct also. Hey, nice job. So let's do Claire's way. I kind of like Claire's way. So, I mean, if a squared plus b squared plus equals c squared works, well, we got a problem. We don't know how long this line is, right? Oh, sorry, Claire. I thought that was a great idea, so sorry. Well, let's try another way then. So if they're perpendicular, right, it's got to be 90. How can I prove they're perpendicular with their slopes? So here's how I'm going to start. Let's find the slope of AB, and let's find the slope of BC. And if they have opposite slopes, they've got to be perpendicular, okay? So the slope of AB is that undefined one. It is really up 1 over 0, up 1 over 0. So AB is really up 1 over 0, which is undefined, right? And the slope of BC is over 0, up 1, over 0, up 1, over 0, up 1. And they really are opposite slopes, okay? So they are opposite slopes. And what we've learned is if two lines have opposite slopes, then they have to be perpendicular. So if they're perpendicular, so I can say AB is perpendicular to BC, okay, I like that. Then if they're perpendicular, they absolutely have to be right angles. So we can say right at the bat that angle ABC is a right angle, right? So therefore, dot, 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 that means therefore. You don't need to know that, but I'll put therefore. Little triangle, dot, dot, dot means therefore. Therefore, triangle ABC is a right triangle. Isn't that a little bit easier to prove than going through a whole 2-column proof? And it does the whole trick, because what we need to do is prove that that was a right triangle. We did it by saying the lines are perpendicular. We got a right angle. Does that make a little bit of sense? Okay, let's look at the second piece. Now the second piece says find the midpoint of AC. So the midpoint of AC, let's take a journey. So if I want to find the midpoint of AC, we're going to go halfway. This is over 1, 2, 3, 4. This is up 1, 2, 3, 4, 5, 6. Half the journey would be 1, 2, 1, 2, 3. There's the midpoint, okay? So let's label that D. All right. So then show the area of ABC is twice area of DBC. So DBC Highlight it so we can see which triangle I'm talking about. Okay, DBC. Right. Well, I've got to show the area of ABC is twice that. Let's first of all find the area. So let's find the area of triangle, the big one first, ABC. And of course the area of any triangle is just simply, 1/2 base times height, right? 1/2, area of a triangle is just simply 1/2 base times height. 1/2 base times height. So the area of triangle ABC is 1/2. Let's see, the base is 1, 2, 3, 4. And the height is 1, 2, 3, 4, 5, 6. Half of 24 is 12. Okay, so that's 12 units squared. Okay, that's the area of ABC. So what about the area of triangle BDC? All right, area of triangle BDC. Let's figure that one out, okay? So again, same formula, right? 1/2 base times height. So, okay, 1/2. The base is 1, 2, 3, 4, right? And the height is 1, 2, 3. Half of 12 is 6. I think I've proven it, haven't I? So is the area of ABC twice the area of DBC? Yes. Went from 12 to 6, right? Yes, I've proven it. Don't you like those better than those darn 2-column proofs, right? Me too. Sorry, the bad news, we're still stuck with those. Till the state changes their competencies. Okay, example 2. Everybody good so far? All right, example 2. So this should be easy. Well, what's this coordinate right here? What do you think? Close. Huh? A0. Yes, A0, because you have to go over A, up B. Nice job. What's this coordinate? 0B, right? Because you go over 0, up B. Not bad. Okay, example 3 is a little bit trickier, but not too bad. Well, I can get the height pretty easily. I can get this part, the y value. I can get the y value pretty easily. What do you think the y value is? What's the y value? What's the height here? Well, it's B, right? Because the height here, if that says B, then that's got to be B, so that's B, right? What about the length? C and? It's both, because if you go, here I'll show you how it works. If you go over a value of A right here, and then you extend out this value of C, then the length is A and C, so it's A plus C. Do you see how that is? A here, and then add your C here, it's A plus C. That was a little trickier, wasn't it? A plus C. How am I doing, okay? Ready to turn the page? All right, the big one. Whew, I know we can do it. I have faith. Okay, here we go. So let's use coordinate geometry to prove a theorem. So to show the two triangles are congruent, I'm going to have to use, if you guys look at the board right by Eduardo, do you see it? We're going to have to use one of those. Side, 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 angle, side, angle, side, angle, hypotenuse, leg, angle, angle, side. We've got to use one of those, okay? And this time what we're going to do is plot some points. So let's plot it. So K is -2, 1. L is -2, 3. There's L. M is 1, 1, 2, 3. There's M. So we need KLM. That's my first triangle. Okay. So first triangle. And now I want to prove also MPK. So let's go M. M is going to be at 1, 3, so I have M. P is at 1, 1. And then K is right here. Well, I think the easiest way to do this is by side, side, side. I think we can do it by side, side, side. I think so. I think we do, and we could do side angle side also. We could do side angle side because you can prove that's a right angle and that's a right angle. We could do it by side angle side. But here's what I know. The length of LK is 2, right? And the length of MP is 2. I mean, I can just count it, right? I just like, okay, I can count 1, 2, 1, 2, right? I think I can show the length of KP. What's the length of KP, you guys? 3. And I think I can show the length of LM. What's the length of LM? 3. Now there's one other thing. I could have two choices. I could go for the angle. I could show right angle, right? Or I can show that this side is equal to itself. Wouldn't that be easier? I can go straight to saying, oh, wait a minute. Isn't KM congruent to MK? And that's by our reflexive, right? So what have I proven? I've proven side to side, right? I've got a side to a side. I've got another side to another side. And I've got the third side. So I've proven it by side, side, side. So I'll finally say triangle KLM is congruent to triangle MPK by side, side, side. What do you think? Not too bad? All right. Homework. Not that many. I've got 4, 10, 15, 24. Because I want you to work on your egg drop. Because we're going to try and drop your eggs on Friday, okay? So let's go through the week. I think we're going to have a test on Thursday. We're going to do eggs on Friday, okay?